Betelgeuse is so big that if you were to place it in our own solar system, it would stretch to the orbit of Jupiter.
It's so easy to think of our sun as this incredibly gigantic thing, but our sun is absolutely tiny compared to some of the giant stars in the sky.
A big, giant, dramatic end to a star's life.
Things frequently go boom in space. Explosions in space are not the end, they frequently mark the beginning. For instance, the explosions of large stars disperse crucial components throughout the cosmos. Heavy elements are also created by the powerful explosions themselves. You too are composed of stars. Also, when stars erupt, they can create enormous nebulae. NASA has discovered several dramatic explosions and collisions in space, including one that was purposefully induced by humans. What significant occurrences both within and outside of our solar system are these in particular? What is this massive, extraordinarily potent explosion in space that scientists have just discovered? Let's find out. Gamma-ray bursts, also known as death from space, are the most potent type of cosmic explosions currently understood by science. These galactic events are so fierce that their awesome intensity is only surpassed by the Big Bang itself. A multinational team of astronomers has now spotted one of these intense energy bursts in unprecedented clarity, allowing them to view a distant massive star in its devastating final moments for the first time. These space-traveling jets of energy must be produced by something incredibly powerful, and supernovae, the collapse and explosion of massive stars, are theorized by scientists to be the cause of these phenomena. A star must be extremely massive, at least 8 times the size of the Sun, in order to go supernova. Yet a star must be between 30 and 40 times as massive as the Sun for a supernova to create the strongest sort of gamma-ray burst. It is likely that we will only see anything of this magnitude once every 10 years, thanks to the rarity of this very powerful detection, which originated from such a potent star. Catastrophic occurrences known as gamma-ray bursts are caused by the explosion of huge stars 50 times as big as the Sun. The process can release as much energy in a few seconds as a star the size of our Sun would in its entire lifespan. These powerful flashes are believed to happen frequently, but fortunately, they typically take place in galaxies billions of light years from Earth, protecting us from powerful jets of particles shot at the speed of light from falling stars. Given that these bursts typically only last a few seconds, scientists find it difficult to study them because we have no advance notice of them. This extraordinarily intense burst was distinct due to the fact that its tightly focused gamma rays were accidentally directed at Earth, allowing our telescopes to detect it and react in real time. We cannot forecast where or when a gamma-ray burst will occur, since they occur absolutely randomly in space and time. Our telescopes were prepared to record the visible light as well as the high-energy gamma rays from the explosion itself because it was quite bright and generated a very brief flare that lasted just 1 second before the main explosion started. It was so dazzling that binoculars could have been used to see it. This is unusual. The event known as GRB 160625b occurred on June 25, 2016, and the first ever detection of it may help us understand how gamma-ray bursts are even able to exist. After such a stunning collapse and explosion, you might be curious as to what will happen to the star that exploded. These explosions, according to scientists, are thought to result from a dead star collapsing into a black hole. Black holes are mysterious celestial objects. Black holes are regions where the matter has been compressed extremely tightly. Earth would only be an inch across if it were hypothetically squashed into a black hole. The mass of our planet would be entirely contained within the object and would still be incredibly huge. As a result, there will be a location with a gravitational pull so powerful that even light cannot escape. Stronger gravitational pulls are produced by massier objects. Particle jets are launched outward as this process proceeds, but until today, It was unclear whether the jets were driven by matter or by the black hole's magnetic field. The explosion, which was discovered by the NASA Fermi Gamma Ray Space Telescope and quickly followed by observations by the Russian Master IAC telescope at the Teide Observatory in Spain's Canary Islands, also revealed that the initial brightest phase of the burst is caused by a type of radiation known as a synchrotron radiation, which happens when electrons are accelerated in a curved or spiral path. Black body radiation and inverse Compton radiation were previously proposed as potential culprits by scientists. However, the degree of polarization in the light burst caused by GRB 160625b shows synchrotron radiation is the most plausible choice. The researchers concede that there is still so much we don't know about these strong beams, but they believe that this understanding could assist to resolve the long-standing enigma of what causes gamma-ray bursts. To find out more, we'll need to catch a view of another really severe explosion taking place far away from us, preferably somewhere we can avoid unless we want to take the brunt of the fallout. But as the researchers acknowledge, it's impossible to predict when that could occur or whether it would be as illuminating as GRB 160625b's exceptional brilliance. With large telescopes like the Submillimeter Array Radio Telescope atop Mauna Kea in Hawaii, astronomers are currently observing the aftermath of the tremendous gamma-ray burst. Therefore, the cosmos continues, a star perishes, the birth of a black hole, and 2 billion light-years away, sentient life notices it all occurring. In addition, a massive enigmatic explosion was discovered in outer space. A massive explosion was reportedly spotted by scientists 130 million light-years away. An enormous collision between two neutron stars, which are collapsed stars and possibly the densest things in the cosmos, was previously discovered here. But the powerful energy that was released by that dramatic incident started to diminish. 3.5 years later, something fresh and different has produced another strange surge of energy. There's something else happening now. Ido Berger, a professor of astronomy at Harvard University and one of the scientists who detected this new cosmic event. The strong energy burst was detected by NASA's Chandra X-ray Observatory, which looks for emissions from the universe's most extreme hotspots. It is compared by astronomers to the sonic boom produced when a fast airplane crosses the sound barrier. There are two hypotheses put out by astronomers, none of which has ever been observed, that would explain the phenomenon. First, there's a kilonova glow. A what? You did hear that correctly, a kilonova glow. According to the theory currently held to be the most plausible, a collision between two neutron stars, bodies so exceedingly dense that a teaspoon of one weighs around 1 billion tons, created a kilonova, or exceptionally bright explosion. Kilonovas could have a significant impact on both the cosmos and human existence. Scientists believe these explosions forge key atoms and metals like gold and platinum. It is one of the alleged primary locations for the universe's heaviest components. Nonetheless, astronomers contend that debris extended into space after this massive kilonova explosion, producing a shockwave or blast. Everything nearby was heated by the blast, including gases and stardust. From millions of light-years away, we can see this kilonova glow or afterglow. Black hole. Another theory is that the violent neutron-star merger produced a black hole, which is an object with such powerful gravitational pull that nothing, not even light, can escape from it. Now, matter from the collision is falling into the black hole. When debris enters the area, it swirls around the potent black item and releases energy in plenty. This could be the origin of the recently discovered energy coming from far-off space. Not far off, scientists were astounded as they witnessed a big starburst for the first time. Astronomers had never before directly seen the explosion of a huge old star, but in 2020, researchers on a mountain in Maui used a big telescope to find a far further red supergiant than Betelgeuse that was exceptionally active at some 120 million light-years away. They paid close attention to it for 130 days, giving themselves a priceless perspective of the climax. Supernova 2020 TLF is the name of the ensuing stellar explosion. There is no close-up video because this star's explosion occurred in the galaxy NGC 5731, which is located far from our Milky Way. Any stars observed through our telescopes that are far outside of our galaxy typically appear as dots. However, the astronomers used special imaging equipment at the W.M. Keck Observatory located atop the lofty Mauna Kea in Hawaii, sensing the explosion was about to occur, to observe the climatic powerful flash and intense release of energy. Even in a faraway galaxy full of bright stars, the explosion stood out. One supernova is all that is needed to outshine all the other stars in the cosmos. Boom! NASA hit an asteroid and captured the collision on camera. The asteroid-moving effort by NASA was a huge success. The project, known as the Double Asteroid Redirection Test or DART, was humanity's initial attempt to deliberately nudge a celestial object. The mission was an experiment to see how a civilization could change the course of a dangerous asteroid, should one ever be on a collision course with our planet. The rocky target, Dimorphos, is not a threat to Earth. Dimorphos, which was around 6.8 million miles from Earth at the time of the collision, was not intended to be destroyed. Instead, a vending machine-sized spaceship was intended to just smack the stadium-sized asteroid. The asteroid was slightly moved by scientists, proving that it is possible to change an asteroid's trajectory. A tail tens of thousands of miles long was produced by the collision, which launched about 2 million tons of rock into space. The experiment was successful because the hit greatly shortened Dimorphos' orbit around its parent asteroid, Didymos. This is an illustration of NASA's broad research of asteroids and other minuscule bodies in our solar system. The first step was to hit the asteroid. Now we are using the data to learn more about the composition and formation of these bodies, as well as how to protect our planet from asteroids in the future. The Moon, however, features a peculiar brand new crater, but this one is not natural. The impact location of a recent rocket accident that took place in early March of last year was discovered on the far side of the Moon by NASA's Lunar Reconnaissance Orbiter, which started studying the Moon in 2009. The powerful impact that caused a double crater, a 19.5-yard crater overlapping with a 17.5-yard crater, was captured on camera by the space agency and revealed in June of last year's picture. It was predicted by astronomers that a misplaced rocket booster would collide with the Moon, marking the first documented instance of space debris accidentally striking our natural satellite. Yet a twin crater was something NASA hadn't anticipated. It was expected to find a double crater, which would mean the rocket body had substantial masses at either end. Generally, the mass of a spent rocket stage is concentrated at the motor end and mostly consists of an empty fuel tank. The double nature of the crater may provide clues as to the identity of the rocket body, whose origin is still unknown. In addition, when a massive meteorite crashed into Mars, NASA discovered an even greater discovery. A spectacular Martian image was captured last year by NASA's Mars Reconnaissance Orbiter, which has been zipping around the red desert planet for 15 years. It is of a brand new crater that is roughly 500 feet wide and 70 feet deep. Yet what the meteor discovered when it struck Mars, enormous, boulder-sized shards of ice blasted out of the crater, has possibly astounded scientists as much as or more than the observed seismic activity. This area, the warmest on the globe, had not yet shown any evidence of underground ice. Of course, we are aware that Mars's poles have water ice. With access to ice at these lower latitudes, which can be turned into water, oxygen, or hydrogen, we would want to place the astronauts as close to the equator as feasible while preparing for future human exploration of Mars. That might be really helpful. Thanks for watching another episode of Voyager. While you're still here, make sure to click the video on your screen